Hello again. To date we've been talking mostly about the mechanics of defining data collection plans and using EDA to get detailed equipment data into factory applications. A question we get frequently is, well, what factory applications are those? What do people do with all this advanced data collection capability? Well, even though Symmetrics is in the business of enabling equipment suppliers to provide data using EDA, and factory application developers to collect that and put that into their systems, we've been involved in this process for many years and have a good idea of the dominant uses of that data in these factory systems. So I'll cover a little bit of the high-level picture of what applications can leverage EDA data. First and foremost, as we saw in earlier discussions, it's very easy to connect a simple client application to a piece of equipment, upload the metadata, and to collect the basic information about that tool's behavior. So having a generic quick connect production monitor is a very common use for EDA because it's much simpler to see what the tool is doing, especially if the model in the tool is compliant to E164. You can make a lot of assumptions about the names of the modules, the wafers, the locations, the process jobs. All of this information is standardized. And so you can quickly get an idea of what the equipment is doing, what processes it's running, and what wafers it's processing without any custom software whatsoever. So this is an actual very quick way of doing a sanity check connecting to a tool. Once you've done that, of course, the next step that most process and equipment engineers do is actually try to characterize that behavior. And a very common initial use of EDA is just improving equipment and process visibility. So once you have the model, you understand all the parameters that are available to be collected. You can plot those in Excel or on strip charts or in other analysis applications. It's very easy to do to collect all the events and parameters available and just see how they behave. Now, of course, once you've characterized the tool, the very next sort of production application that most people implement is multivariate fault detection. And this is actually the predominant application of EDA data to date in the industry. Because in order to do well-architected fault detection applications, you need to frame the trace data very carefully. You just care about high-speed data probably in a certain number of recipe steps, not before and after certain conditions are established. And so you can use EDA's powerful event-based data collection to actually frame the data that you want and put that into your multivariate control models. Of course, another thing that once you understand the tool's behavior and have good fault detection application, you then start to use it to compare tools across a fleet. And so a set of similar equipment you want to have behaving in the same way, and maybe you have one that behaves very well, but you're not quite sure why. So you do what's called a golden run analysis on that equipment, and you compare the key trace variables in one with like variables in similar equipment to see where the differences are and perhaps why those differences exist. Another key application, of course, is that we're seeing interest in now is external sensor integration. So people are now starting to take EDA and to use that as a way of presenting information collected from independent sensors alongside the information collected from the equipment, use a shared model to actually unify that data so that the analysis applications downstream believe that that data was collected from a consistent single integrated source. An EDA model is an ideal way to do that. Finally, in advanced wafer fabs, it is important not to have substrates sit around after they've been processed. The inter-process times are very important for some advanced fabs, and so knowing when a lot is going to complete ahead of time so that you can schedule the material handling systems to pick up that material and move it to the next process. Knowing when that's going to complete ahead of time is precisely a very important application. And EDA is an ideal way of predicting that using the information in the model. So we'll talk about these last two applications, external sensor integration and lot completion estimation. We'll talk about those two in more detail in a separate discussion. Thank you.